Step into rediscovery, where cosmic marvels and the magic of science come alive. Have you ever gazed up at the sun and wondered about its true color? Is it really the bright yellow we often imagine? Or is there more to the story? Most of us throughout our lives have drawn the sun as a cheerful yellow orb in our childhood drawings. This image is ingrained in our minds from a young age. It's a question that has sparked curiosity for centuries. Is the sun truly yellow? Or is there more to this celestial puzzle? The answer might surprise you. The answer, like the light itself, is multifaceted and fascinating. The sun emits light across the entire visible spectrum and even beyond. Our everyday experience seems to provide a simple answer. The sun appears yellow, especially when it's low in the sky. This is due to the scattering of shorter wavelengths of light. But what if I told you that the sun, the very heart of our solar system, isn't actually yellow at all? In fact, the sun is essentially white when viewed from space. What we perceive as the sun's color is the result of a captivating interplay between light, our atmosphere, and our own eyes. The Earth's atmosphere scatters the shorter blue wavelengths, making the sun appear yellow to us. Buckle up, space cadets, as we embark on a journey to unravel the mystery of the sun's true color. We'll explore how light behaves, how our atmosphere affects it, and what this means for our perception of the sun. To understand why we perceive the sun as yellow, we need to first understand the concept of light and its spectrum. Light, as we know it, is a form of electromagnetic radiation that travels in waves. These waves vary in length, and each wavelength corresponds to a different color. Sunlight, like all light, is made up of different colors blended. This blend of colors is what we call the visible light spectrum, which includes all the colors we can see with the naked eye. Think of a prism splitting a beam of sunlight into a rainbow. That's the visible light spectrum in action. The prism bends the light, separating it into its constituent colors. Each color in the spectrum corresponds to a different wavelength of light. For instance, blue light has a shorter wavelength compared to red light. Red has the longest wavelength, while violet has the shortest. This variation in wavelength is what gives each color its unique properties. When all these colors combine, they create what we perceive as white light, and that's precisely the color of our sun. However, this white light can be scattered and filtered by different elements. So, if the sun emits white light, why does it look yellow from Earth? The reason is due to the scattering of light by the Earth's atmosphere. The answer lies with our planet's atmosphere, which acts like a giant filter, altering the way we see the sun's light. The atmosphere scatters shorter wavelengths like blue and violet more than the longer wavelengths like red and yellow, making the sun appear yellow to our eyes. When sunlight enters Earth's atmosphere, it collides with tiny particles of air, water vapor, and dust. These particles are so small that they interact with the light in a unique way, causing it to scatter in all directions. This collision causes the light to scatter in different directions. The phenomenon is not random but follows specific physical principles. This scattering effect, known as Rayleigh scattering, is more effective at shorter wavelengths, particularly blue and violet light. However, our eyes are more sensitive to blue light, which is why we predominantly see a blue sky. As a result, these colors are scattered away from the direct path of sunlight, leaving behind the longer wavelengths of yellow, orange, and red. This is why the sky can take on such vibrant hues during sunrise and sunset. That's why the sky appears blue. We're seeing the scattered blue light. The blue light is scattered in all directions, making the sky look uniformly blue. The more atmosphere the sunlight has to travel through, the more pronounced this scattering effect becomes. This is especially noticeable during sunrise and sunset when the sun is low on the horizon. This explains why the sun appears more yellow or even orange or red at sunrise and sunset when it's low in the sky and its light passes through a thicker layer of atmosphere. The increased distance causes more scattering of shorter wavelengths, leaving the longer wavelengths to dominate the sky's color palette. Atmospheric acrobatics, how air paints the sun's portrait. Think of it like this. Imagine shining a white flashlight through a glass of water with a few drops of milk added. The milk particles scatter the light, making the beam appear slightly yellowish. Now, imagine increasing the amount of milk. The beam would appear even more yellow or even orange. That's essentially what's happening with the sun and our atmosphere. The air molecules and other particles act like the milk, scattering the blue light away and leaving behind the warmer hues. So the next time you see a vibrant sunset, remember that you're witnessing the atmosphere's artistry, painting the sky with scattered light and transforming the sun into a fiery spectacle. A cosmic canvas, the sun's appearance across the solar system. If we could travel beyond Earth's atmosphere and observe the sun from space, we'd witness its true color in all its glory, a brilliant, radiant white. Astronauts have confirmed this firsthand, describing the sun as a blindingly white orb against the black backdrop of space. This difference in perception highlights the profound influence our atmosphere has on our view of the cosmos. It's a reminder that even our most basic observations of the universe are shaped by the unique characteristics of our planet. Beyond the yellow haze, embracing the sun's true brilliance. The sun's true color, that pristine white light, is a testament to its immense energy and power. It's a fusion furnace, constantly churning out light and heat that sustain life on Earth. So while we may continue to enjoy the familiar yellow hue of the sun in our everyday lives, let's not forget its true nature, a dazzling white star at the heart of our solar system. Understanding the science behind the sun's color adds another layer of wonder to our appreciation of this celestial wonder. It reminds us that there's always more to discover, even in the seemingly simple things we see every day. Keep exploring. The universe of light and color awaits. The journey of exploring light and color doesn't end here. There's a whole universe out there, filled with celestial objects emitting and reflecting light in countless ways. From the fiery glow of distant stars to the ethereal auroras painting our own skies, the cosmos is a canvas of vibrant hues waiting to be explored. So keep asking questions, keep observing the world around you, and never stop being curious about the science that shapes our understanding of the universe and our place within it. After all, as we've learned from the sun, sometimes the most familiar sights hold the most fascinating secrets just waiting to be unveiled. Thanks for tuning into Rediscovery, where every journey reveals awe-inspiring wonders. Hungry for more mind-blowing adventures? Tap that like button, share your thoughts in the comments, and subscribe to keep the exploration alive.